Hello students, today we will study about the refining of metals by the process or by the passage of electricity. Okay, so electro-refining of metals, that is purification of metals, will do here. Electro-refining, it is a process by which metals containing impurities, if metals are containing impurities, they are purified electrolytically to give a pure metal. Okay, so electrolytically will purify a metal, impurities will be removed from it and will obtain a pure metal. The term refining means to make pure, and electro, the method employed to make the metal pure. Okay, by electrolysis, by the process of electrolysis, we'll purify the metal. Now see how this happens. This is the electro-refining of copper. It is the apparatus set up here. See, this is the, we can easily see this is the thinner electrode and this one is the thicker electrode. Yes, this thicker electrode, it is impure copper. We have to purify this copper, and this is the cathode. Cathode means negative electrode, which is very thin sheet of pure copper. It is very thin sheet, it is of pure copper, and this is the thicker block of impure copper, which is made positive. Okay, because it is connected to the positive terminal of the battery. This is called anode and this is cathode. Here the electrolyte which we have taken, it is aqueous solution of copper sulfate. See, aqueous solution of copper sulfate means it will dissociate into Cu plus 2, SO4 minus 2, and along water is also there, means H plus and OH minus ions are there. Okay, what we have to do here, we have to purify this impure copper and we'll get this pure copper here. See, when the process will continue, we'll see that this impure copper, this block, it will start becoming thinner and this pure copper will start becoming thicker. Okay, now we'll see how this will happen. See, electrolyte which we have taken here, it is aqueous copper sulfate solution and it is acidified. Acidified means a little amount of dilute sulfuric acid it is added here to increase its dissociation and conductivity. Okay, now nature of electrodes, two electrodes are there, cathode and anode. Cathode, it is pure thin sheet of copper, while anode, it is impure block of copper. Okay, dissociation reaction it will take, like copper sulfate and water will be there. So copper, it will dissociate to give Cu2 plus and sulfate SO4 minus. Water is also there, water will dissociate to give H plus and OH minus. Now we'll see the reactions which will be taking place at cathode and anode. At cathode, here what will happen, copper metal will deposit here. Okay, it means if copper is depositing here, it means reduction reaction will take place here, and here the copper metal, it will lose 2 electrons and will come here in the solution. So from here, copper in the form of copper ion, by losing copper atom, they will lose 2 electrons and that copper ion, it will come in the solution, and copper ions from here, they will move here to this thin pure copper, and here they will reduce themselves by gaining 2 electrons and they will form copper atom, and that copper atom, it will start collecting over this thin pure sheet of copper. Now see, at cathode, Cu2 plus, they will gain electrons and copper will be deposited over there, over this thin sheet, and copper plus 2 ions, they are discharged at cathode as copper atoms. Thus pure copper deposited on the thin sheet of pure copper, it is placed at the cathode. Reaction at anode, if we are talking about, it is an active electrode, and here again the fight will be between sulfate and hydroxide. They both will migrate towards the anode, but neither are discharged there. Instead, what will happen? this copper atom, it will lose 2 electrons and it will change into copper ion. This electrode it will give copper ions, and sulfate and hydroxide ions, they will remain here in the aqueous solution. What we'll see, Cu2 plus ions in solution, hence anode diminishes in mass. It diminishes in mass and it will start becoming thicker. The impure block of copper gets used up and the impurities settle down. Whatever are the impurities, they will settle at the bottom of this anode, and these impurities are called anode mud. And these impurities, they may contain the traces of iron, zinc, even sometimes platinum and gold is also present over there. The pure copper metal dissolves out from the copper anode, that is the impure copper block, and the Cu2 plus ion formed in the solution at the anode are deposited at the cathode, that is on the thin pure sheet of copper. Here they will deposit by gaining 2 electrons. Okay, the impurities present in the impure copper anode, they will settle down as anode mud, or it is also called slime, and they contain the insoluble impurities like gold and silver. Impurities such as iron, zinc, etc., the higher in the electrochemical series ions and dissolves in the electrolytic copper sulfate solution. These impurities, they will dissolve here, and the impurities like gold and silver, they will collect here as anode mud. Now, metals generally refined by electrolysis. Metals which are extracted by electrolysis, that is highly electropositive metals, are already deposited at cathode in pure state, and hence they need not to be refined further. Zinc, lead, copper, mercury and silver are thus generally refined by the process of electrolysis. So this is how we can purify the impure metals. We can do it by the process of electrorefining. Yes, electrorefining. Yesterday we studied about electroplating. That was a plating of a superior metal on a baser metal, and it is electrorefining. Here we'll refine the impure metal, and that impure metal, it is made anode, and anode mud is collected here, and the pure metal, it is made cathode. Okay, thank you.